Hey YouTube, Booth Dog again. Here we are, Tuesday of our second week of this new experience for us all. Hope you're doing well. Continue to reach out to me if you need absolutely anything. Before we get started for today, just want to point out that today's video is sponsored by pencils. Lots of pencils. And not those trash mechanical pencils either, but real wooden pencils that actually work. Now, since some of you have started complaining about the lack of, shall we say, decent editing in some of these videos, I guess I'll capitulate. Let's bring on Mr. Boothman and get started. All right, let's go. Good morning, happy Tuesday. Let's jump right in. So, brief announcements. You have an exit ticket as always that will be due by midnight tonight. Today's will actually have a couple of questions for you to answer. I promise they're not difficult. Just kind of check in and make sure that you're following along with the video, okay? Today we're starting our very last section of the year. Very sad, I know. Section 10.5. Convergence. Okay. Now, we've talked a lot about different types of series, of Taylor polynomials that approximate different functions and so on. But really, a series itself, and this is a question some of you have asked me in the last month or so, a series itself is only useful where it converges. Right? Because when a series converges, we've shown, when a Taylor series converges, it is equivalent to a function. It represents a function. And so we can use it instead of the function. So the rest of this unit, this last section, is devoted to showing how we prove that a series converges or diverges. Okay. Now, there's a little vocab associated with that, so I'm going to spend today kind of going through some terms that we've discussed before, but I want to clarify a little more, distinctions between those, and then we'll dig into a bunch of different tests for convergence of a series. Okay, so let's start by talking about some important terms. Okay, we have the radius of convergence. We have the center of a series, and we have the interval of convergence. All right, so I'm going to draw on a number line here. Let's say A, right here, is the center of our series. And this should make some sense, right? We've talked about our Taylor series. We're centering it at A, so each term has x minus A. We're plugging in A to all of our derivative values. The radius of convergence, R, is literally the distance around A for which the series will converge. Okay, so of course it should converge at its center, and then how far away from the center does the series actually converge? So this is our radius, which means that our interval of convergence is going to be from this to this value. So this is A minus R, this is A plus R. So our interval of convergence is A minus R to A plus R. That's kind of it. The first page of your mastery sheet, which I do want you to work through today, so please work through the first page of the mastery sheet, 10.5, is literally just questions like this. So for example, a series centered at x equals 3 has a radius of convergence equal to 4. What is the interval of convergence? Well, if we're centered at x equals 3, and the radius of convergence is 4, then we're going up to 7 and over to -1, which means our interval of convergence is from -1 to 7. That's literally it, okay? So different types of ways I can ask this question, but regardless, like, this is an important skill to have. Notice that I am not including the endpoints here. Testing for endpoint convergence would have been section 10.6. It's not included in the AP exam this year, as we all know. So we're not going to talk about it, thankfully, to be perfectly honest, because it does get kind of tricky at times. I'm still more than happy to discuss it with you if you want to reach out and find out more, or feel free to explore on your own. But for now, just know we would have to test for the endpoints separately. So again, work through this first page of your mastery sheet. Problems just like what we just did. And this brings us to about as far as I want to go for today. This last section is going to give us a few more ways of testing for convergence. Now, we actually know a couple already. The first goes back to the very beginning of this unit. We had what's known as the nth term test. The nth term test. So it occurs to me that you don't have your notes. Okay, so let's go through this together. I was going to ask you to go back through it yourself. The nth term test tells us that if the limit as n approaches 0 of the nth term of a series does not equal 0, I'm sorry, the limit as n approaches infinity of the nth term of a series does not equal 0, then the series diverges. Okay, now thinking back, conceptually, this meant that if our very last term, if the nth term of a series at some point equals 0, then as we keep adding more and more terms, since at a certain point those terms start to equal 0, our series should converge. It should actually equal a real value. If there is no point at which our nth term, at which some term in the series actually equals 0, then we're just going to keep adding numbers forever and ever, which means our series will diverge. Okay. The second test that we actually already have is our test for a geometric series. If a series is geometric, then we know it converges to a over 1 minus r, where a was the first term in the series and r was the common ratio of the series. Okay, so we used this, we exploited this quite a bit when we were talking about geometric series and power series near the beginning of this unit. Okay, we are going to add a few more tests as we go through 10.5. We're going to talk about the next one tomorrow. Until then, I really just want you to kind of ease into this, focus on that first page, take your exit ticket due by midnight tonight, and join our Google Meet. Reach out to me if you have any questions or concerns. All right, see you tomorrow. All right, well, I hope that was informative for you. Continue to reach out to me with any of your questions or concerns. Yes, Shelby, it's okay if you have questions, just reach out to me. You too, Arter, and I'll see you tomorrow.